Hello students, our today's topic is AC amplifiers. Now before going into AC amplifiers, hope you remember that op amps can process both AC signals as well as DC signals. Okay, it can amplify AC as well as DC signals. So today we'll see how it works with AC. Okay, so let me draw the circuit. So in this AC amplifiers, you will be studying uh, your basic configurations of inverting amplifier, non-inverting amplifier. Okay, so we call them as capacitor coupled non-inverting amplifier, and other one is capacitor coupled inverting amplifier. Okay, let us see one by one each today. Okay, let us start with the first one. Yes, capacitor coupled non-inverting amplifier. For this, first you should draw non-inverting amplifier. This is for non-inverting, means this should be grounded, right? There will be one feedback resistor. We call this as RF, right? This will be some resistor. We'll name it later because I want to change the suffix here. Then we used to ground this, right? Yeah, this will be there, plus VCC minus VE. This is what your non-inverting amplifier is, right? Yeah, sorry, I made a mistake here. Here we used to connect VS. Okay, here VS because AC amplifiers, right? So I'll be supplying AC voltage. Now this part capacitor coupled non-inverting means there is a slight change here. You need to couple a capacitor both at input side as well as output side. Okay, input side means here before giving supply voltage you need to have a capacitor. This will be C1. This is your supply voltage. Here you will be having a small resistor called R1. If this is R1, this can be R2. You can also interchange their names. Okay, this can also be R1 and R2. Position is important, not the name. Okay, here also RF is written in some textbook. You will find R3 or R2. Okay, name may change. Let the name change, but their location, their position is very important. Okay, and output side, this will be C2. Okay, here we can have one resistor RL, load resistor. So this is what the capacitor coupled non-inverting amplifier circuit is. Now the question is why C1 and C2 is added. So students, listen carefully. C1 and C2 is added to block DC voltages, to block unwanted DC voltages. Now what is this? Why it is unwanted? Because we are using this circuit as an AC amplifier. In AC amplifier only AC signal is to be amplified, right? Only AC is to be amplified. We don't want any unwanted DC to be present in the signal. So even if DC is present in the signal, DC will be blocked by this capacitor. Okay, DC cannot cross over your capacitor. Okay, it will be blocked. Only AC will be passing. Okay, only AC will be passing. Here also, while driving a load, we want pure AC to come out, right? Even if some DC is created, because we are already using plus VCC and minus VE, there is some chance that some DC may be involved, some DC signal may get added into our output. So we don't want that to come out. So before taking it out, we are blocking it with another capacitor C2. So C2 will take care that no DC is coming out, only pure AC is coming out. Okay, and C1 will take care that no DC is coming into the circuit. Okay, only AC will be passed. So this is the role of C1 and C2. So in your design part, you need to calculate the value of R1, R2, RF. Then you need to calculate the value of C1 and C2. Okay, you need to calculate the value of C1 and C2. Now before going into C1 and C2, let me tell you how R1 is calculated. For this R1, we write 0.1 VBE divided by IB max. This is fixed. I can say you have to assume as it is R1 equal to 0.1 VB IB max all the time. Okay. When you should not assume, I will tell you. Okay. When it is required. Now what is this VB? This VB is 0.7 volts. What is IB max? Remember, IB max is 500 nano amperes, a very small current, very small current. Fine. So this IB is flowing across R1. Okay, this is always assumed to be 500 nano amperes. 500 nano amperes. VB is 0.7 volts. So this will give you one, that is 140 kilo ohm. So this may be your first problem. Okay, so in most of the cases it will be 140k only. Okay, so I want you to remember this. This is the formula. Fine. This is the formula. R1 equal to 0.1 VB IB max, where IB is 500 nano amperes and VB is 0.7 volt. Okay. Now this is about R1. Okay. Now let us see for C1 and C2. Okay. Now to find C1, which is at the input side, right? C1 is input side, C2 is output side. Now let me simplify this circuit for your understanding, so that I can use voltage divider rule. This is our C1. Right? This is our C1 and this is our R1. Right? Applied voltage is Vs. Correct? And the voltage here is, let me call it as Vn, which is going into your op amp, input voltage for your op amp, right? Now I can write using voltage divider rule. You remember voltage divider rule? We can write using voltage divider rule, that is, if I want Vn, this Vn voltage, how can I write? Voltage in the opposite branch. What is that voltage in the opposite branch? It is Vs here, right? Into the resistance of present branch, that is R1. Vn is across R1, right? So this resistance you have to take for Vn. divided by sum of the impedance. Here we have R1, right, and C1 plus C1. How to write for capacitance? We have to write how? Yes, XC, right? XC plus XC or minus XC? You should write minus J XC 1 because we have C1. So this is how you have to write. Now if I say you that we require only magnitude here for our simplification, I can write like this: R1 square, this becomes plus XC1 square, right, by taking only magnitude. This is what we require. Now what I want is, if we apply this as input Vs, we want everything to reach as input. We want all of this to reach till this point. That is, Vs should be equal to Vin, right? Maximum or the everything should reach till our input side. For this condition, what we should have now, to have Vin equal to Vs, what should we do with this equation? We want this should equal to this. This can happen only when this R1 is equal to this term, right? This numerator should become equal to this denominator so that I can cancel this and I am remained with only Vin equal to Vs, right? So for this whole term R1 square plus XC1 square, right, should become equal to R1, isn't it? If this whole term becomes equal to R1, then this R1 and R1 gets cancelled. I am remained with only Vin and Vs. Vin equal to Vs. So for this to achieve, now if this whole term should become equal to R1 means this term, right, XC1 square, this term should become very small compared to R1, so that I can, if I ignore this, I am only remaining with R1. Just see, if I take out this XC1 square, I am only remaining with R1 component, right? This equal to this. Now for this, we assume that for this to achieve, XC1 term, this component should be very small compared with R1. Hence we assume XC1 equal to R1 by 10. Means 1/10 of R1 we assume for XC1. Okay, this is what we assume. Now how to use this, I'll tell you. We know that, I'll write it here. We know that Xc is equal to 1 over 2 pi Fc from our basics, right? I'll write it small. Xc equal to 1 over 2 pi Fc. You already know this. Now I can also write this as 1 over 2 pi f Xc, right? So we want C1, right, 1 over 2 pi f. Now instead of writing Xc, what is this? We have Xc1. Here for our example, right? So for our example, I can replace this Xc1 equal to R1 by 10. 2 pi FL, L stand for lower cutoff frequency, Xc1. Instead of writing Xc1, I have to write R1 by 10. So this is how you have to find out C1 value. Okay, R1 will be assumed, right, 0.1 VBE by IB max, that divided by 10 into lower cutoff frequency will be given to you in your problem, then you will get C1 value. Fine. Now similarly we will also see how to find C2. Okay. Yes, I am going to replace this C2. Just see here, this is C2 and this is your RL, this part. Okay. This will be your V naught, output voltage of op amp. This will be the voltage across load, VL. Right. Once again we can write using voltage divider rule. I want, okay, I am doing this to find capacitance C2. Fine. Now I want VL. How to write? Voltage in opposite branch V naught into same branch resistance, right? RL minus JXC2. If I take only magnitude, VL V naught RL divided by RL square plus XC2 square, right? This is what we get. Now the thing is, when XC2 becomes equal to RL, XC2 becomes equal to RL, why I'll tell you, VL is going to become equal to what? Tell me. If this and this becomes equal, then this becomes 1 plus 1, right? Then 1 plus 1 is 2. Root 2, it becomes root 2. So I can write here root 2, right? So 1 by root 2 is 0.70777, it goes on like that, right? So VL is going to be 0.707 V naught. Okay. You cannot make this like how we did for C1. Okay. You should get like this. You should get 0.707 V naught. I'll tell you why. So that VL becomes V naught minus 3 dB. What is this minus 3 dB? So for an op amp, the gain of your op amp when it falls down at lower cutoff frequency, okay, at this 3 dB down is needed. Okay, there is a concept for this, why 3 dB is required, what is this cutoff, upper cutoff frequency, lower cutoff frequency. Okay, when I get time for this, I'll explain later. Fine. Now for this to achieve, to get this minus 3 dB, this 0.707 is must. Okay. So from the above equation, the lower 3 dB frequency occurs at when you take RL equal to XC2. RL equal to XC2. These things are in very detail, not required for you to go in deep. Okay. Now, therefore, we know that, what is that? XC is equal to 1 over 2 pi FC, right? So, like previous thing, I am going to replace this. So, C2 will become equal to 1 over 2 pi FL. This is going to become, like last time it was R1 by 10, right? So, this time it is going to become only RL. Only RL because XC is equal to, XC2 is equal to RL. Okay. So you have to remember this. This is C2. C1 is 1 over 2 pi FL R1 by 10. Important equations. R1 is 0.1 VBE by IB max. What is IB max? Yes, IB max is 500 nanoamps. VB is 0.7. Then what is remaining? Yeah, R2 we find like this, Vs divided by I2. Okay. Where is this I2? I2 is the current flowing through R2. Current flowing through R2. Okay. Where I2, yes, this is very important, where I2 is 100, where I2 is 100 times of IB max, 100 times of IB max. Important, very important. Fine. All these things you have to assume as it is. Don't make any changes. All these are fixed values. Nothing to be changed. Okay. As it is you have to use. Fine. What is remaining? Yes. The gain, closed loop gain will remain 1 plus non-inverting amplifier, right? 1 plus RF by input resistance. Here it is R2. This R2. Okay. Not R1. RF by R2. 1 plus RF by R2. So this is what your capacitor coupled non-inverting amplifier is. Similarly, we can also have capacitor coupled inverting amplifier.